right, this is lesson 122 of Algebra 2. Don't forget to subscribe, like, turn on notifications. We're on page 494. All right, lesson 122. We're going to do the second part of it first, talking about the intersection or the union of sets. We have already been doing this, like negative infinity, 6, 7, infinity. We've already been doing the union of sets. That means it is both of them. It is in it is both of those solutions. But now it's going to look and feel a little different. Let's suppose I have two sets. I say set A. The elements of set A are 1, 2, 3, 4. 1, 2, 3, 6, and 7. And I say B is, this is actually on the bottom of page 494. B is 1, 3, 8, 9. 1, 3, 8, 9. When we use union, we were saying it was both of those, right? So the union means it's in both of them.
So 1.
The union means it is in both of them. So we're going to list all of them. So U means to the union. The union of the two sets. So it's all the numbers in the sets without repeating them. So you're going to put all the numbers in the sets without repeating. All right. Now, if I have an upside down U, that means the intersection of them. The intersection is the numbers they have in common. That's the numbers the sets have in common. All right, so if I just said, what is A union B? It's all of them. 1, 2, 3, 6, 7, 8, and 9. It's just all the numbers in both of the sets without repeating them. On the other hand, if I did A intersection B, it would just be the ones they have in common, which are
3 and 1.
1 and 3. That is correct. So y'all know, y'all have used this before, because if I drew this, it would be 1, 3.
Ooh.
This would be A, that would be B. So 2, 6, and 7 would be here, and 8 and 9. What is this called? Venn diagram. That is correct. All right, so the intersection is the ones that they share in common. The union is just all of the numbers. Does that make sense? Pretty easy. Without repeating. Yes. All right, look at example 2 on page 495. Now we have sets P and Q. So P is 1, 2, 3, 4, 7, 9, and 13. And Q, the elements of Q, K rather, I renamed it Q. K, I think Q is better, but 2, 5, 7, 8, 13, 15. Now, what if I said I want to know P union K? What would that look like? 1,
2, 3, 4, 5, 7, 8, 9, 13, 15.
Does that make sense? What if I said the intersection of P and K?
2, 7, 13.
Okay, y'all, that's easy peasy, right? What if I gave you a diagram?
Wait,
I
are you
said
gonna give
this-
us a Venn diagram on the exam?
You just don't even know. A, B, C. All right? Well, no, let's do this. Let me erase this. That's circle A, B, C. All right. What if I said A intersection C? Make sense? What if I said A union B? It would be all of that. All right, does everybody understand union and intersection? It's pretty straightforward, right? All right, the second part of this lesson is the laws of logs, which I gave you a handout. Everybody have their handout? All right, so we can expand and we can expand or we can condense logarithms. It's all based on the arguments. When the arguments are multiplied, what do? Multiplication is?
Addition.
We add them individually as logs. So when the arguments are multiplied, we can expand it by adding individual logs. When individual logs are added, we can condense it by multiplying their arguments. We can go both ways. So multiplication is addition of logs. Division is subtraction of logs. Raised to a power, we multiply. All right? So we're going to practice expanding and condensing. I gave you the solutions for all of these. All right, because we're not going to work all of them. All right, look at number 1. Log x to the 4th over y to the 6th. We're going to expand it. What goes first? What happens first?
X to the 24. 24.
I'm going to move 6 out front. Because raised to a power, we multiply. So it's going to be 6 times the log of x to the 4th over y.
Why don't you do it on the exponent? Like, would it make it any different?
Well, we could have made each one of those. X to the 4th raised to the 6th, y to the 6th. But really following order of operations, I would take care of my exponent outside of a parentheses first. All right, now what do? What's division?
Subtraction.
All right, so that's 6 log of x to the 4th minus 6 log of y. Now what do I do with that?
Put it with multiply to 6.
Multiply it. So that's 24 log of x minus 6 log of y.
Is that your answer?
That's it expanded, yes.
Wait, so what's the problem? Is this
Expanded.
That's the lesson.
Make a single log expanding it, yes. All right, now we're going to go the other way. We're going to look at an expanded log and we are going to condense it to a single logarithm. You have to know how to go both ways for the test because, well, I'll say that in a minute. All right, let's do number 9. 5 log base 311 plus 10 log base 3 6. Okay. What's the first thing I do? I want to make it a single log. So where does this 5 go?
On top of the 11.
As the exponent. Where's the 10 go?
On top of the 6.
As the exponent. So this is log
It's power raised to a power.
base 3, 11 to the 5th. We're putting it back in its exponent position. Log base 3 of 6 to the 10th. Now addition is multiplication of the arguments. Log base 3 of 11 to the 5th times 6 to the 10th. And that's a single log.
That's the answer.
That is the answer. Yes. All right, you're going to have to be able to do this when we have equations. So I'm going to remind you, there are 2 types of logarithmic equations. One, where it's all logs. All right, so I'm just going to make it up. All right, I'm going to leave the base 10. Log of x plus 3 plus the log of x minus 1 equals the log of 12. Every term's a log. When every term is a log, that's when you want to condense your logs. You want to write them as a single log. You want a single log equals a single log. So addition of logs is multiplication to the arguments. So that's a log x plus 3 times x minus 1 equals a log of 12. Once I have a single log equals a single log,
You dropped the log.
drop the logs, set the arguments equal to one another, and solve for x. Now, what do I have? We're going to say negative 10 plus negative 10 on that side. Actually, we'll just add 10 over here. I'm just going to add 10 over here. All right, so I have log, constant.
Boo!
When I have a constant, I want a single log equals the constant. So I'm going to subtract log of 12. All
Oh.
right. All right, so I want to set all my logs on one side of the equal sign, leaving my constant on the other side. Then I want a single log equals a number. All right, I do it one step at a time. Addition is multiplication. Subtraction is division. Now what do I
And
do?
you're gonna like.
Go to exponential. What's my base?
10.
10 to the 10th. Base to the exponent equals the argument. And solve for x. Okay, so there's only 2 types. You will have both types on this next test, which is a week from today.
I like
Both types meaning.
All logs, logs with a constant.
So that's the answer?
No. We're solving for x. You're going to actually finish the algebra.
Okay. Oh.
Multiply by 12, multiply the numerator, set it to 0. I'd probably use the quadratic formula. I just made this up, so who knows if it'd be a real or imaginary, right? I don't know. All right.